Here are a few more examples to help us find the probabilities associated with the standard normal distribution. Our first one here is asking us to calculate the probability of observations less than a z-score of negative 0.89. In other words, they want to know what percent of values lie to the left, right? Left because it's less than here. What percent of values lie below or to the left of a z-score of negative 0.89. My recommendation is to always draw a picture and label the mean, and since we're talking about the standard normal distribution, we know the mean is 0. Our z-score is negative 0.89, so it's to the right. The negative sign tells us to the right, or excuse me, to the left of the mean. And I want to know what percent is below this, so I'm going to shade to the left. Thankfully, because the chart, if I know the z-score, the chart will convert, the chart that I'm given will convert the z-score to the area to the left. So all I need to do is to look up a z-score value of negative 0.89 and see what I'm given. So I'm going to look that up on the chart. Negative 0.89. I am not dealing with a positive z-score, I'm dealing with a negative z-score. See up here to the picture shows a z-score, it's giving us the area to the left, of negative 0.8. Here is the row that I'll be using. And I want to go over until I hit 0.89. And if I look above, 0.09 in the hundredths place is the last column. So I'm going to go negative 0.8 all the way over to this value right here. I get 0.1867, 0.1867. So on the chart, I get 0.1867. So what I just found was the probability or the percent, and you can write it as either. If I'm asking for a percent, you should write it as a percent. If I'm asking for a probability, you should write it as a probability. I think students usually like to convert it to percents because it makes more sense to them as a percent. 18.67% of values lie to the left of that z-score of negative 0.89. Now, if we go to the next one, we're looking for what percent of the values lie above. This greater than is telling us to the above or to the right of 1.45. So again, we'll draw our picture. The mean is 0. Here's 1.45, and I am looking for the area above. Now here's the key. If you look up a z-score of 1.45, let's look that up on the chart, see what we get. So let's look up 1.45 on the chart. This is a positive z-score. If I get 1.4 and go all the way over to the column for the hundredths place being 5, I get 0.9265. 0.9265. Now, this picture should kind of tell us here, this is associated with 92.65%. This picture should lead us to think, wait a second, that might be wrong. This is not 92%. The reason why this is indeed incorrect is because remember the z-score chart is giving us the area to the left. So when I look up 1.45 on my z-score chart, what I'm getting is actually the area here to the left. That's okay though. I mean, although it's not the answer, it allows us to get the answer with one more step. Remember, the area underneath the entire curve is 1. So if I take 1 and I subtract this 0.9265, then I'm going to get what's remaining and what's above. So if I subtract that, 1 minus 0.9265, I will get 0.0735, which is also 7.35%. 35%. The key here is to realize the chart will only give us the area to the left. So if you want the area to the right, then you're going to have to subtract that from 1. I'm going to give you the opportunity here to pause this video and try this next one. Okay, I've gone ahead and completed this problem. I see that the probability is asking for, I'm looking for the probability or the percent of values that lie above a z-score of negative 1.38. It's above it because it's greater than, which means I'm looking for the area to the right. I drew my picture, I labeled my z-score, and in red I shaded to the right because that's what I'm looking for in red. When you look up negative 1.38 on the chart, you get 0.0838. However, as I know from working with the chart, that area is here in blue. Every time you use the chart, you will be given the area to the left of that value. So when I found 0.0838, I shaded that in here to the left, labeled it, and realized if I want the area to the right, then I'm going to have to subtract from 1. That's going to give me the remaining part to the right. So if I subtract 0.0838 from 1, I get 0.9162, which is associated with a percentage of 91.62%. 91.62% of the values lie to the right, or lie above a z-score of negative 1.38. The final one's a little tricky, and that's because we're not just looking for the area to the left or to the right, but what I'm looking for, if I were to label this z-score, or excuse me, label this chart, here's 0, I want to know what area is between a z-score of 1.31 and 2.46. So I'm actually looking for the area between. You'll have to forgive my drawing. I am looking for the area between two z-score values. Now, I am going to look up both of these on the chart. So a z-score of 1.31 and a z-score of 2.46. When I look up 1.31, what do I get? 1.31 gives me 9049, so 0.949, 0.9049. And when I look up 2.46, what do I get? 2.4 and go over to the column of 6, I get 0.9931. So what this is telling me is that 99.31, if I were to convert this to a percent, 99.31% lies below all the way from 2.46 all the way down here. So what I'm going to do is just change colors here, and underneath I'm going to just mark what that gives me. Everything below 2.46 is all of this. So I know that 99.31% of all of the observations of the area here lies below 2.46. So that is this entire area. I don't want this entire area. All I want is what's between 1.31 and 2.46. So if I could only take out, I'm going to switch colors here, and I hope it's not going to confuse you, but if I could somehow take out this piece is what I want gone. I want to take out all of this. If I could start with this 99.31% and take out this piece in green, then I would have exactly what I'm looking for, this piece in red. Well, it turns out I know this piece in green. That is 0.9049. That is everything that's below the z-score of 1.31. Right? That's why when I am given a problem like this and I'm asked to find in between, I will still use both and find both z-scores and both areas associated with those z-scores. To get my solution, I have to take the area to the left of 2.46, which I got to be 0.9931, and I'm going to subtract away the area to the left of 1.31, the area there, which was 0.9049. When you subtract those, you should get 0.0882, which if you were to convert this to a percentage, that's 8.82%. The area to the left is the area in between these two z-scores accounts for 8.82% of the values, which is also the same as saying we have a probability of randomly selecting an individual or an observation of 0.0082 is our probability of selecting an observation between these two z-scores. In other words, and one final way of saying it is, given a normal distribution, something that's normally distributed, 8.82% of the values will occur or will be between 1.31 standard deviations and 2.46 standard deviations. I do want to briefly mention that a common mistake with this problem is that students remember that you have to subtract values, but instead of finding the areas and then subtracting, students will incorrectly subtract the z-scores. So subtracting 2.46 and then minusing 1.31 and then finding that, and that is incorrect.